Okay, so the question is saying that let A be a 3 cross 3 matrix over complex numbers with a trace 1 and determinant 1. Suppose further that one of the eigenvalues of A is 1, then which of the following statements is necessarily true? The characteristic polynomial of A has repeated roots. Every eigenvalue of A has absolute value 1. A does not have any eigenvalue on the imaginary axis. And fourth one is saying that A square is the identity matrix. Okay, so firstly note that trace of A is 1, determinant of A is 1. Okay, so now suppose that let lambda 1 and lambda 2 are other two eigenvalues of A, and it is given that 1 is one of the eigenvalues. Therefore, eigenvalues of A is equal to lambda 1, lambda 2, and 1. Okay, so these three are the eigenvalues of A. Now, I know that trace of A is equal to sum of the eigenvalues, means lambda 1 plus lambda 2 plus 1. This means 1 is equal to lambda 1 plus lambda 2 plus 1. This means lambda 1 plus lambda 2 is equal to 0. This means lambda 1 is equal to minus of lambda 2. Okay, so name this equation 1. Okay, so now note that determinant of A is product of the eigenvalues of A. This means lambda 1 into lambda 2 into 1, and 1 is equal to determinant of A. So I'm replacing the value of determinant of A. So lambda 1 into lambda 2. Therefore, lambda 1 into lambda 2 is equal to 1. Okay, so now replacing the value of lambda 1 from 1 to 2. Okay, so name it 2. Okay, therefore I get minus of lambda 2 into lambda 2 is equal to 1. And this means lambda 2 is equal to plus minus iota. Okay, so now I have lambda 2. Therefore, lambda 2 is equal to plus minus iota. Now, if lambda 2 is iota, means plus iota, then lambda 1 is equal to minus of iota from equation number 1. Okay, so, and if lambda 2 is minus of iota, then lambda 1 is equal to plus of iota. So in general, therefore, clearly 1 iota and minus iota are eigenvalues of A. Okay, so now I will go to the options. So the firstly, let me write that eigenvalues are plus minus iota and 1. Okay, so it is saying that the characteristic polynomial of A has repeated roots, which is false, since roots of characteristic polynomial are the eigenvalues and none of the eigenvalues is repeating. So 1 is false. Okay. Now, second is saying that every eigenvalue of A has absolute value 1. Okay. So let we find the modulus of these. So note that modulus of 1 is 1 and modulus of plus minus iota is 1. So 2 is correct. Okay. And the third one is saying that A does not have any eigenvalues on the imaginary axis, which is false since plus minus iota are on the imaginary axis. For option number 4, it okay. So option number 4 is saying that A square is identity matrix. Okay. Now choose a matrix A such that 1 0 0 0 0 1 0 minus 1 0. Okay. So if we square this matrix, then I get 1 0 0 0 minus 1 0 0 0 minus 1. Okay, which is not equal to identity, and the eigenvalues of A are and eigenvalues of A are 1 and plus minus iota. Okay, so some of you thinking that how I made this matrix. So I made this matrix with the help of this note. So according to this note, that if I have a special type of matrix, then I can find the determinant of A by this way. Here A1, A2, An are square matrix, but not necessarily of same order. Okay, so in general, let me solve this for you. Okay, so let if I choose A is equal to 1 0 0 0 0 minus 1 0 1 0. So if I want to find the eigenvalues of A, then I will find in this way. So I get 1 minus x 0 0 0 minus x minus 1 0 1 minus x. Okay, so now I will make this A1 and this is wait, this is A2. So now determinant of A minus xi, which is equal to determinant of A1. This means 1 minus x, as it is 1 cross 1 matrix, and determinant of this. So its determinant will be x square plus 1. This means x minus 1, 1 minus x, and x minus iota, x plus iota. Okay, so with the help of this note, I can make counter example immediately. Okay, so I choose A in this way, and A square is not equal to identity, but eigenvalues of A are this. So fourth is false one. Okay,